Good morning, everybody. A very warm welcome to all of you. Welcome to nasscom's inaugural Cloud Summit 2021. As part of India's journey towards a digital nation, cloud computing technology is going to play a central role. Cloud computing is the platform on which all other digital technologies would converge, and without cloud, digital transformation in its true sense may not take place. It is in this context that nasscom envisaged the Cloud Advocacy Program that aims to increase the conversation around cloud and in the process transform business to transform India. The Cloud Summit 2021 is the first event under this umbrella of the Cloud Advocacy Program, and we kickstart this two-day event with 3 workshops. The first workshop today is on innovative open source technologies for cloud feature microservices development. And to conduct this workshop, we have Mr. Gautam Jain, who is Global Director, Public Cloud Security and Data Protection from NetApp. Just to introduce Gautam, he has over 20 years of experience in building market-ready products from concept phase to design, implementation, and go-to-market. Domains of expertise include on-prem and cloud product design engineering, product management, cloud security and operations, OEM business development, technology acquisition and integration, and ISV and offshore vendor management, both in startup and enterprise environments. Gautam, over to you.
Thank you very much, Diksha. Thanks for the introduction. And so welcome, everyone. Good morning to all of you. Welcome to this session on cloud native microservices. And so we will walk through over the next 45 minutes to an hour, really getting into slightly at a higher level in terms of the open source containerized microservices development environment and how it has evolved in terms of technology, architectures, user personas, and what's been the adoption and where do we actually go from here. So without further ado, let me go to the next slide. So just one more slide back. Yeah. So here is a quick recap, if you will, of evolution to the cloud native era over the last 30 years. The application architectures, the delivery models, the underlying infrastructure from on-prem to cloud has transformed significantly in the last 30 years. So this picture actually shows you a time break view starting 30 years ago from 1980s to 1990 and a little bit into 1990, which is the horizontal, first horizontal line, and then how it has evolved over the next decade and the decade after. So what you see in the 1980s to close to the year 2000 is the development processes have primarily been waterfall. Right? And we have all who have been working in the last 20 to 30 years, we know that waterfall has been the predominant development process. The application architectures, the on-prem applications, as we know, are monolithic in nature. They are very big. Everything is intertwined and depends upon each other. You tweak one piece and it impacts the entire application stack. Obviously, IT, there was physical servers, bare metal, deployed in the data centers. And that was sort of the overall architecture, the development process. And it had its own advantages. It evolved over a period of time. But as we move into the second row is around the year 2000 to 2010, cloud sort of started taking its presence. Our most beloved vendor came in, and it actually disrupted the way development was done, the way the applications were deployed, and the way everything from infrastructure to applications were consumed. The public cloud sort of put a pressure on the legacy IT vendors, customers to actually go ahead and have IT as a service. So they had private clouds, quote unquote, the private clouds came into existence. The development processes went from waterfall to agile, where you really did not have to wait for too long to acquire something. You could design, you could redesign, and that led obviously in collective format to building 3-tier architectures or N-tier architectures. VMware, right? Virtualization, analogous to VMware, where you had virtual servers down from physical servers to virtual servers, consolidation significantly increased. So obviously the development cycles reduced from in the year 2000 because of the agile processes. Architectures were more granular in terms of the 3-tier architecture. Server consolidation efficiency went significantly up. A little bit of consumption model was brought in where customers in-house built automation, built private clouds. They started offering IT as a service to their own users. And that had its own benefits, but still, and during which time, when you go further into the 2010 and beyond, there was, even though we had built this agile 3-tier virtual server consolidations architectures, there were still inefficiencies from the perspective of you could not build applications or request the infrastructure in a dynamic way. It was still not elastic in nature. The IT processes still made sure that you had to go through the entire process. So then came the year 2000 and probably until now is the development processes changed significantly in terms of DevOps. Everybody is familiar with the idea behind DevOps. Fully integrated, fully automated. The monolithic architectures were not elastic in nature. They were very heavily intertwined. And then came the concept of microservices. Microservices have been there for actually quite some time, but they really helped build applications in multiple components, hundreds of components with a very clearly defined message passing infrastructure. And then came containers. This is the vertical evolution from physical servers to containers, where containers basically provided a package around all the microservices. They were infrastructure agnostic. They were very portable. You could really take a microservices based architecture embedded into containers and deploy it anywhere. And all of this obviously was brought in by cloud, right? Cloud really helped take this, put a lot of pressure on IT to really go ahead and evolve. So hopefully this gives you guys a history of evolution to the cloud native era. Now, let's take a look at, see, what we talked about in the last slide is about application architectures, right? But at the end of the day, there are consumers. So if you look at the consumers in the left-hand side, which is your on-prem legacy infrastructure world, you build applications with a segregated teams. There was an application development team, there was the platform, and there was the infrastructure, right? And we refer to this as the infrastructure-driven application world, where the application team would go ahead and design an application. They would request the resources from the platform services. From the platform team, they go down to the infrastructure, very sort of vertically integrated, but there were these layers in between that introduced sort of a lot of delay. And it was primarily driven by infrastructure-driven applications. You design an application, you request an infrastructure, and then you have to wait when you need to acquire more infrastructure. For example, if you want more resources, you have to request to IT, and then you would have to wait. As the time evolved into sort of the cloud native 1.0 world, there were new personas that emerged. You have heard of site reliability engineers, which are familiar sort of with the cloud world, cloud operations team. DevOps team. Basically, what happens is these new set of personas aligned with the microservices-based architecture, and they needed elasticity, flexibility, and they needed, so for example, if you look at the application development, it was basically 3 layers on subscription model: infrastructure, platform, as well as software as a service. And we refer to this particular change in application-driven infrastructure because these personas even further evolved into, for example, data scientists. And data scientists actually did not want to manage infrastructure. They wanted infrastructure to be completely transparent to them. So what you see in the picture that's vertical is how applications started getting built. Streamlined, vertically integrated, where teams don't have to necessarily worry about infrastructure, and that lend into you decide what infrastructure you need, you request that infrastructure on a dynamic basis, and that is elastic in nature, and it continues to grow and shrink based on your demand. But the life cycle of the development actually significantly reduced with these new personas. So hopefully that gives you another dimension from the architectures on the first slide to the personas and the evolution of personas and what they actually needed. So now I wanted to this is an important slide, and I wanted to share a framework within which we will actually take a look at the different architectures, the different eras, and what benefits, what were the challenges, and how it actually evolved into this framework. So at the end of the day, the line of business, the CIO, the thing that he worries about at a high level the most is, hey, the 3 dimensions. And we will take a look at these 3 dimensions: efficiency, the IT efficiencies, the operational efficiencies, the innovation at the bottom in terms of low on the top bottom left to high on the right hand side, and then the cost. These are the 3 most important pieces when you're writing, you're allocating budget. How efficient are you? Are you using technologies efficiently? Are you operationally efficient? Are you innovating fast enough? Because that becomes sort of a competitive differentiator. And then the cost. We all know in the past and even today, the budgets are constrained. You don't have a whole lot of money that you can go ahead and spend unwittingly. You have to control your cost. So this is the framework that I will really go ahead and build on top of in terms of our architectures and how they have evolved to where we are today and where we are going. So with that, now the first one, we talked about the legacy infrastructure. That was the first line on the first slide, right? Waterfall development processes, all data centers occupied with physical servers and monolithic applications. And this was the era where IT had evolved for such a long time that they became really, really efficient. They controlled everything in terms of services that they are providing to their customers, to their users, and the infrastructure as well. And this is, we refer to at the 1980 to 1990 timeframe. It was predominantly infrastructure driven. You design an application, you request an infrastructure, but the problem was because of the stringent and the efficient IT controls, basically led to miserable rates of innovation. So for example, if there is a line of business within an organization that want to try out and build a big data application, they needed an infrastructure to start with, and they needed to scale up that infrastructure very, very quickly. You needed to complete that project instead of 6-month release cycle, you needed to complete that in let's say a month or even 2 weeks. So the notion of innovation here really refers to the ability to fail fast, right? Start quickly, fail fast, continue to evolve and develop. So in this era, right, the IT controls were very, very efficient. It was predominantly on premises. Applications were driven by the infrastructure, but you just absolutely could not innovate, right? It was just not possible to move fast enough. Now, let's transition into what happened between the beginning of the year 2000 to that entire decade. What happened is public clouds came about. They disrupted every aspect in terms of how the products or applications were built, how they were deployed. And public clouds were actually this, liberty to the application teams, because I could actually start a project, request some infrastructure, and as I need more, I don't have to necessarily go ahead and wait for a month for the underlying infrastructure to be procured, deployed, and then be available to me. I could just go ahead and swipe my card, request 100 more compute instances, additional storage, which was elastic in nature, all provided by the clouds. Or for that matter, as I mentioned earlier, there was this notion of private clouds hosted. So a combination of those two with changes in the development process, which was more agile in nature, you basically had these three-tier architectures that were, we have all heard about this term called service-oriented architectures. And this is where customers, line of business, application developers were able to innovate, and they were able to innovate significantly faster because of the elasticity of cloud, agility of the development process, these three-tier architectures, etc. But what happened, and this is an important point, is everybody was free. Line of businesses had some budget. They started off. Application developers failed fast. They acquired more infrastructures. And what happened was the cost of development increased significantly. All of us have been shocked in the early days with the bill that we get from our cloud vendor, right? It was hard to understand the bill. It was huge in nature in terms of the cost of development significantly increased. And it was natural, because I, who used to rely on this efficient IT controls in the past, had a free hand, swipe my card, allocate infrastructure, and there was nobody, quote unquote, managing what I was requesting from the cloud. So for example, if I requested, 5 compute instances, I may or may not shut them down when I'm not using them, right? But the bill continues to, it's 24/7 billing cycle. And all of us were really shocked by the bills that we got. So we started, the rate of innovation definitely increased, but with massive cost overruns. And there was absolutely a need to go back into the right quadrant where I reduce my cost of development, but I have to continue my innovation, right? I cannot go back in time. So I need those flexibility, elasticity of cloud, and I need to get some of the operational efficiencies back. So now what I'm going to do is I'm going to leave the third top right rectangle open. And now we will dive a little bit more deeper into the constituents of how do we get to that third quadrant. Operationally efficient, innovation continues to increase or continues to stay where it was and increase, and the cost is low. So now we will take a look at the third row that I had shown you in the first slide in a little bit more detail in terms of how did we get to the adoption of those different architectures and technologies and so on. So I have just highlighted in blue the 4 constituents, the 4 pillars, if you will, and what I refer to as Cloud Native 2.0. So let's take a look at each one of those a little bit more in detail to help us really lead to that third quadrant where we achieve the objectives for line of businesses and the CIOs. So everybody knows in terms of how did DevOps from continuous integration with technologies like Jenkins to continuous deployment with CloudFormation templates into the cloud, and then which evolved into continuous optimization. So if you look from the left to the right, basically what it shows you is a little bit of a process which talks about how do you go about developing your application and why it takes as long as it takes in the world of waterfall on-prem. You design an application, you decide to go ahead and use a certain database, for example. And while writing your code, you realize that, well, you need to make some changes. Either you need more infrastructure or you may even need to switch the database. You go back to IT, request additional infrastructure, and wait for a week, 2 weeks, sometimes even a month, right? And this whole iterative cycle in the waterfall world basically led to the amount of time was significant. In this particular example, and it's just an example where it shows how it would take you 5 weeks plus to go ahead and accomplish and build your application, build a feature for your particular application. Agile is sort of in the middle, but we will take a look at what happened when when DevOps became prominent, from continuous integration to continuous delivery and constant optimization. Basically, all the waiting period that you had, because the fundamentals of your design did not change. Whatever iterative changes you needed to make, even in the DevOps world, because it was a design challenge, you had to go ahead and make those changes. But every instance where you made a change in your decision, whether it's an architectural deployment, underlying infrastructure, you did not actually have to wait, because you were sort of using the cloud or the cloud concept, where you could go ahead and request those resources in an elastic way, just swipe your card, get those resources, so you could move a lot faster. What happened is what you used to build in about 5+ weeks reduced to, in this particular case, 11 days. So the key takeaway on this and with this example is basically the DevOps model helped you deliver software quickly in a more agile fashion. It obviously did cost money because you didn't have the checks and balances, but it helped you move faster, which sort of ties back into the comment around innovation. Because one of the things and the competitive differentiator is how quickly can you build an application, which is an iterative process. How quickly can you fail and then you recover from it, and how quickly you can get to your end state. So hopefully this gives you a perspective in terms of what DevOps really helped us deliver from a development process standpoint, basically agile. Now, one of the common questions that comes up, and you have probably heard about, hey, well, microservices actually have been there for quite some time. The concept of building smaller modules with a message passing interface that's well defined. So what has changed? And this is where during the late 2000s, open source was a liberty, right? Open source significantly contributed to what was microservices-based architectures were deployed by or adopted by a few, but it was not ubiquitous. Not everybody was using it, and there were many reasons for it. So cloud open source contribution, let's quantify. What does it really mean when we say open source contribution? On the left-hand side, what you see is open source significantly contributed to the adoption of the microservices architectures, along with technologies like Dockers and containers. Open source, people did not get one. Initially, when microservices architectures were introduced, it was offered by a few vendors, and customers were wary, enterprises particularly were wary of not getting vendor locked in. So in terms of quantifying between 2016 to 2023, the adoption of microservices architecture, the amount of money that's going to be spent on technologies of microservices, Dockers, containers is going to significantly grow. The spend is going to grow at 17% all the way to $33 billion. So hopefully that gives you, in terms of the adoption of microservices, particularly pushed from open source, and it was a quote unquote nirvana for people. But let's take a look at the qualitative aspects in terms of what are the business benefits. As I mentioned, one of the things is the IT budget. Just because you had cloud and you had the elasticity and the flexibility, did not mean that your budget could significantly increase. Yes, the cost did increase, but over a period of time, the pressure continued to increase on the software budgets, right? And this is why, so one of the biggest benefits of microservices, especially open source contribution, is it helped start reducing your budget because of its architecture. We talked about improved time to innovation, the bottom right, in terms of how the agile methods of development, cloud, the 3-tier architectures really helped customers improve their time to innovate. And then one of the biggest benefits, the third line, is because of the open source contribution, the integration with other open source technologies, because a lot of people were contributing, bringing in a lot of innovative ideas and technologies. And it also reduced the risk of vendor lock-in, right? Because it was open source and by definition. The fifth one is actually my personal favorite, community-driven innovation, right? Innovation can be done by one vendor, which can probably lead into lock-in. But when the open source community starts contributing to innovation, which is called community-driven innovation, it significantly changed the landscape in terms of integrations, in terms of no vendor lock-in. So this was the total benefits in terms of open source contribution to microservices. So hopefully it gives you an idea in terms of how open source led to the adoption, and obviously it was driven by business benefits. Now let's look at the adoption of cloud native microservices based architecture. Let's quantify a little bit, not in terms of the microservices spend, but in terms of what were some of the reasons that led to switch of these microservices. Obviously, part of it is just microservices design. The other is the open source that led to 63%, right? 63% to 92%. The biggest favorite of mine is the 69% of where of enterprises are using. Yeah, the bottom right, the 69% is when originally when cloud native applications were built using microservices based and container based architectures, the potential benefits were so much so that enterprises who are running these legacy applications on-prem ask the question to themselves in terms of, why can I not use the design concepts of microservices, the benefits of microservices containers to my on-premises applications? So this is in the process. This is still evolving, and customers are taking a look at their enterprise applications and how they can go ahead and really take the concept that was predominantly cloud native in nature or applied to cloud native applications and apply it to their legacy applications as well, because these legacy applications on-prem monolithic 3-tier architectures are not going to disappear right off. So these are some of the metrics that actually define in terms of what were some of the reasons that customers switched to microservices. What you see on the right-hand side is really the early adopters, right? These were the cloud native applications, and they adopted microservices-based architecture. They can scale to unimaginable heights in terms of the growing number of users. And now the 92% of the people are really looking at, or 88% of the people are really looking at betting on microservices. So these were some of the benefits and the reasons that people decided to actually switch to microservices-based architectures. So this was our sort of second pillar, which is microservices. First was DevOps, second is microservices. And then let's take a look at the third pillar in terms of the popularity and benefits of containers. Because of its elasticity in nature, we see the deployment and packaging as microservices became more and more popular, you needed a way to ship those, you needed a way for them to be infrastructure independent so that they could be portable. So that's what containers did, right? Containers really wrapped around all the microservices helps you deliver some of the key challenges that customers started facing. So what are some of the benefits? And the survey basically asked the participants, how important are the following benefits of containers to your organization? One of the things that happened as containers were introduced, because they were wrapping around a lot of microservices, which were talking to each other through a well-defined message passing interface. It was in the cloud, and everybody actually said that, hey, I understand the benefits, but I want better security because of the way these applications are designed. That was the top of mind for all the customers, better security through isolation. And one of the things that is not represented, and I did not talk about, is DevOps eventually, or it's actually evolving into something called DevSecOps, which is essentially operations security embedded into the overall DevOps process. And this was essentially the punchline for all these guys who actually said, hey, we need better security through isolation. And that gave rise to basically DevOps evolving into DevSecOps. The second one is pretty evident in terms of increased server consolidation, because my containers essentially is the, as of today, the last mile of the virtualization. It evolved into containers and continue to deliver the server consolidation and server efficiencies. Because, and then the most important one, greater application mobility and portability, which was extremely critical. You can see that this one actually ties back into what we have talked about in terms of vendor lock-in, right? Nobody wants to be locked in to a particular vendor. Kubernetes, and these are services provided by pretty much everybody now. Azure Kubernetes service, Elastic Kubernetes, and then from Google. And a lot of people are looking at from an open source standpoint also in from companies like IBM and Red Hat. So this was a key requirement. Otherwise, there was no real reason for customers to be able to go ahead and use containers if they were not portable, if they were not mobile, and by definition, they sort of fail fast. The other three are pretty clear in terms of we have seen how the whole thing sort of evolved into the use of the adoption of microservices and containers and so on. So this is the third pillar in terms of the containers, the usefulness of containers, the benefits of containers. Now, obviously, the fourth pillar is a cloud, which we have talked about pretty much throughout our entire 35 minutes. So now I'm actually going to go to the third pillar. Now, we had seen the second slide or the third slide, which talked about the framework. We took a look at the benefits and the challenges with the legacy architectures, how it evolved into cloud native, where the innovation significantly increased, and map those architectures in those rectangles. So now let's take a look at, let's add all this up in terms of how do we get to that right rectangle with all the benefits of microservices, containers, architectures, and so on. So the right-hand side is what I refer to as Cloud Native 2.0. And Cloud Native 2.0 essentially is a culmination of all the technologies coming together, where we retain the rate of innovation because the software development processes just got better from agile to DevOps. The legacy architectures, three-tier architectures evolved into this granular, very portable, flexible architectures with microservices and containers. And even though I show a picture of just one cloud there, it is really important to understand this is a multi-cloud architecture. And we all understand that the world for a significant time is actually going to be hybrid cloud. So all of these technologies combined, the challenges we saw with them and the benefits of microservices and containers really helped introduce some of the cloud optimization techniques, which I refer to in the DevOps world as cloud optimize or continuous optimization. Started with continuous integration, continuous deployment to continuous optimization. And there are cloud native technologies available for cost optimization in terms of how do you efficiently use the underlying infrastructure resources. So hopefully this picture gives you guys a view into the journey of where we started. On the left column, on the top left column, the legacy architectures, applications were dependent upon infrastructure. They were static. They were not elastic in nature at all. That led to increase in the development life cycles. But it was characterized by efficient IT because it had been built over the years. Then we moved into the infrastructure independent applications, which I didn't talk about, but essentially what the cloud did is really helped request for infrastructure independent of the application, so that with agile development processes, you could move faster, but rates of innovation increased significantly, massive cost. And when we combine the benefits of DevOps, containerized based microservices architectures, and really tapping into the different cloud providers, be it public clouds or the benefits of microservices and containers as adopted by even the private cloud hosted vendors or just enterprises in general, so that they can actually take the concept and revamp or redesign their on-prem applications to really take the benefits, the design benefits of microservices and containers. And this led to what we believe the world is going into is the application-driven infrastructure, where, for example, I have a project and I'm a data scientist. I don't really know and I don't really care and I don't want to know about the infrastructure. I have no personas in terms of how applications have to be built all the way from top to bottom, going to the bottom being more cloud native, vertically integrated infrastructure is completely transparent. It scales up, scales down, and all the optimization techniques that are applied to all these four dimensions really help you deliver what the line of businesses, what the CIOs really needed in terms of reducing the cost. It is extremely critical and important because budgets are still constrained and we have to go ahead. Applications have to be built in that context. So with that, I hope this gives you at least a high level perspective on the evolution of the infrastructures, leading to the cloud native era, and how we have landed ourselves into the application driven infrastructure world. Now, let me go to the last slide and let me sum it up. And when I say sum it up in terms of, we talked about the different architectures, the cloud native architectures, microservices, containers, how open source contributed to the significant growth, both qualitatively and quantitatively, to these different architectures. In multi-public cloud, I really wanted to say here is multi-cloud, because it's not just about public cloud, because a lot of the benefits of cloud native are actually getting embedded into the on-prem world, creating this world of hybrid cloud, which is going to be the predominant way of building and deploying applications. And it has helped IT transition, or I would even take it a step further and say customers transition from infrastructure-driven applications, the top left rectangle, to application-driven infrastructures, liberty. Public cloud brought the liberty to the application teams. We took it a step further. Clouds, multi-clouds actually helped increase the rate of innovation. And obviously we saw how the cost had significantly increased, and the cloud native 2.0 architectures, which is still evolving, is getting to a point where we are able to build customers are able to build applications at a much lower cost, utilizing the benefits of all the different clouds. With that, I come to the end of the presentation. I definitely wanted to make sure that we are able to address questions, and I see questions coming in onto the chat. Amar, if there are questions that people want to ask, that's perfectly fine. Otherwise, I'll start addressing the questions that are coming in from the audience. So I see the first questions. What's the difference between Agile and DevOps? A great question. Part of it is, so Agile was brought in terms of the process, right? In terms of, okay, there is a way to go ahead and request additional infrastructure, or I don't have a dependency on another team, which was still there from an IT standpoint. So it was a vertically integrated where parts and parcels were automated. So for example, the pre-development process, for example, continuous integration was fully automated, but the three pathways between continuous integration, continuous deployment, and continuous optimization were not fully integrated. So DevOps is really about continuous integration, continuous deployment, and the continuous optimization pieces all coming together, where it becomes a cycle, and a little bit of AI ML is introduced in that piece to basically have the system learn. And basically, for example, on the continuous optimization piece, the ability to scale up and down the existing infrastructure. For that, you need some intelligence, you need to build. So there is a little bit of that learning process involved in DevOps that leads to something called continuous optimizations. So that was the primary way, or the primary difference between Agile and DevOps, which is fully integrated all the way through the infrastructure as a service, platform as a service, as well as software as a service, fully integrated end to end, from the time you write the first line of code to the time you actually deploy the changes into production, is basically where DevOps really helps from a continuous optimization standpoint. Okay, the next question is from Ayush Tiwari on the main components of microservices. Could you share us how did you resolve one of the use cases challenges during pandemic pre and post ways of working? Let me just make sure I read that correctly. Could you share us how did you resolve one of the use cases challenges during pandemic pre and post ways of working? Great question. I love this question. If you look at the pre-pandemic days, in terms of there was this notion of desktops, right? Desktops were delivered by IT, and it followed the same principle of development. It followed the same principle of delivery. And what we really needed, there was a need for delivering desktops that would perform. When I was working pre-pandemic, I was in the office on a high bandwidth connection. When I moved to, for example, my hometown, the bandwidth wasn't as great. And there was a need to really re-architect, literally, right? Re-architect the delivery model, which was sort of a managed service provider type solution for desktops delivery, to something that is over the internet, that is highly efficient, that is fully integrated from end to end, and that helped actually deliver desktop as a service, which was worked out really well in terms of the latency requirements were addressed because of the elasticity of the nature. It was fully microservices and containerized applications. So that is one example that I can think of between pre and post pandemic, which really helped, especially on the desktop as a service solution. Question 4. Can you give a real life example of a multi-public cloud solution? I understand it's polycloud that you were referring to. So the example that I could really talk about from a multi-public cloud solution, I would probably refer to it as a hybrid cloud solution, where there is a significant need for example, if I'm running an on-prem application and I am doing backups of that on-prem data, and I'm putting it onto a significantly expensive on-prem storage, there was this notion of backup to public cloud, where you could go ahead and use cloud as a repository for storing your backups at a cheaper price, right? So that is a real world example, which gives you a good blend of a hybrid cloud solution. You're doing backups on-prem, but you're storing them, indexing them, putting them into the cloud so that it can be retrieved at any given point of time at the same level of SLAs and granularity that you used to get from on-prem solution. So that's a great example of sort of a solution that blended itself into hybrid cloud architectures. Okay. Question 5. How do you see the product vendors becoming microservices compliant? Okay, versus in-house development? That's actually a very good question, in the sense that the answer is not straightforward because it is still in the evolution phase. So what I see, and I experience it on a daily basis as well, is the product vendors are actually going to become more microservices compliant. One aspect is they have to address the security needs, right? Especially when they are building it into the cloud. One of the big notions or the questions that comes up is, hey, well, if I'm developing microservices, I don't really have to worry about security because it is provided by my underlying infrastructure. So one of the big takeaways for product vendors to be becoming microservices compliant, they have to address the security aspect of the development process. Because what happened with containers and microservices, or containers in general, as they started packaging these microservices, the attack surface of the applications actually significantly increased. So it was a challenge, and we had to resolve that challenge. So as I look at the product vendors becoming microservices compliant, they absolutely have to address the security piece. And you have heard the term DevSecOps, and I believe it is going to become more and more prevalent. There is a need for this, cloud security process and technologies to be embedded into this, and which is great, because as the enterprises in their on-prem world adopt the microservices, they will be able to take the benefits and basically apply some of the security principles of their building on-prem in DevSecOps, or rather the cloud ones, apply them into your on-premises. So that is what I would say in terms of what the product vendors have to. Key takeaway is make sure security is designed into the overall development processes because of the increased attack surface. Question 6, does microservices will fit into stateful applications, for example, databases? Another phenomenal, great question, and I'll tell you why. As containers became prevalent, containers are ephemeral, right? I mean, containers come and go, but applications are not ephemeral. when we built the web applications in the old days, it was okay for it to not have persistent storage. It was perfectly okay. But as the benefits of microservices and containers got realized, we realized that storage or persistent storage was actually not part of this containers microservices based architectures. And it was extremely important to make sure that we address the need for stateful applications. And there are vendors who have actually made available technologies where they have actually made persistent storage not as an afterthought, but they have sort of tried to design it into this containerized microservices based architecture, for example, database as a service, which is stateful in nature. So absolutely, yes. Microservices do fit into the stateful application market, but there are vendors working on the persistence of the storage piece. Thanks for that question. It was a great one. Pankaj Sharma, question 7. Can you give an example where multi-cloud setup was beneficial to drive innovation for application-driven infrastructure? Okay. Can you give an example where multi-cloud setup was beneficial to drive innovation for application-driven infrastructure? Is there any complexity involved that we should be aware of before taking this path? Yeah, so this is a great challenge for all the vendors forward in terms of, in this world, you can get very quickly get confused in terms of what vendors should I choose, from public cloud to people who are building on the on-prem world. So in order to continue on that innovation path for application-driven infrastructures, you have to be cognizant of two things. Standardization. So, and open source, look at open source. Absolutely look at open source, because individual vendors will drive their own agenda, but take a look at open source, because open source, the community of open source people, they are incentivized themselves to go ahead and build applications that are not locked to a particular vendor. So that is the thing that I would, if I were you, take a look at open source, the development of different technologies done by the open source folks, and adopt those. Obviously, at some point of time, you will have to choose a resource or a service from, let's say, a vendor, but see how they are sort of compliant, and are there similarities in the technologies that they actually go ahead and use. For example, Dockers and Kubernetes, for Dockers for Kubernetes and so on. So I would take a look. One key takeaway on that question is take a look at the technologies being adopted by the open source community, because open source will help you innovate and help you make sure that you're not locked into a particular vendor. Another question by Rajneesh Kurup. Can you provide an overview of how all the changes you mentioned has impacted testing, and where we are in the path to achieve optimization of testing in the cloud? Okay. So the thing that I would point out on this is what I mentioned earlier, especially, which is extremely critical and important for testing in the cloud, is DevSecOps. So let me talk about DevOps first, as I mentioned earlier. Continuous integration, continuous deployment. What you need to add to that continuous integration and continuous deployment piece is the continuous optimization. So take a look at technologies that have implemented AI ML to really learn from their systems and be able to go ahead and create or retrofit those technologies into the overall frameworks that is provided by, for example, the public cloud vendors. So that is, and then make sure, as I mentioned earlier, security is part of the development process. Absolutely extremely critical. I have seen where we build an application, security is not inbuilt into design. We are full DevOps ready, the application, and then we run these security tools against the application that we have built, which was really fast. And then we find out all these vulnerabilities, right? Coding vulnerabilities related to, and they are prone to error. Obviously, you've heard in terms of how the phishing attacks happen, the attack surface that has increased. So make sure security is part of it. It will definitely help you, not just from a development, also from a testing standpoint. Test early. Embed security early and test it early versus security being an afterthought. Question 9 from Vivekanand. Thanks, Vivek, for the question. If the way forward is application-driven infrastructure, then is OS part of the infrastructure or not? If yes, how is the application built to address various OS platforms and tested? So instead of reading through the whole question, I think I got the gist of it in terms of, so OS is definitely part of the infrastructure. There is no way that OS can actually disappear, whether we go from the physical server down to virtualized and into containers. So OS is definitely absolutely part of it. What I would say in terms of embedded all the OS platforms and tested the overall development process, take a look at technologies, which is basically open source Kubernetes, and the innovation that's happening on the side of building these stateful applications, which is totally embedded into all the 3 layers, software as a service platform, as well as infrastructure. And make sure that the persistent storage part is absolutely a critical component of what you're building and what you're testing. So you've got to build across the stack, and you have to test it across the stack and tap into Kubernetes as much as possible. And I think for the application-driven infrastructure, it's a no-brainer. You have to go ahead and use a blend of those technologies. Where would serverless, from Money One, where would serverless architecture on cloud lead us to in terms of positioning yourself within the four quadrants? Great question. I should have actually mentioned this. It is on the top right quadrant, application-driven infrastructure. Serverless, I would go even a step beyond. It is not just about the serverless. You have probably heard the term storageless. So this is, if you take a look at the top layer in terms of how the applications need to be built, infrastructure independent, it is not just about serverless, but it's about storageless. Combine those 2 technologies with containers and microservices, you need the portability to avoid the vendor lock-in, and it will fit absolutely on the 4 quadrants. I look at the last quadrant on the top right as what I refer to as cloud native 2.0. We started with on-prem, cloud native 1.0, cloud native 2.0, serverless and storageless. Those are the 2 absolutely critical components to keep in mind. And
Gautam.
Yes, go ahead.
Diksha, I'm sorry. We are running out of time and we have the second speaker waiting. So I think we'll need to close.
Sure, absolutely. And let me know how I need to answer question 11 and 12. Happy to do it.
We can put it up on the website. We'll be happy to coordinate with you. And then we can put it up on a community page and people can refer to it. But I just wanted to thank you, Gautam. It was a very, very excellent, very interesting workshop. And the questions were also equally interesting. Just to quickly sum up, you have talked about how technology has shifted from times where infrastructure dictated application development needs to current where application development is dictating infrastructure. And this has come because of the flexibility that open source technologies allow, and the development of DevOps, DevSecOps, microservices, and containers help. And in the process, they helped achieve the goal of greater efficiencies at lower costs and at faster rate of innovation. And the customer value underlying that is, like one of your slides mentioned, is more cloud at less cost.
Absolutely.
So that sums up. So thank you very much, Gautam. Very, very
Thank you everyone for listening.
Thank you.
And thank you everyone. Take care. Have a good day.